Okay, we have a little bit lighter of a week. Not that anyone's complaining, but this week we have lesson 2.03, which is all about solving radical equations, and we have a quiz. So the 2.04 radical and polynomial operations mid-module quiz. So we have a quiz and one lesson this week. So we're going to look at the lesson, give a summary of that. So anyone who is not up through, you should have had 2.02 turned in yesterday. If you haven't got all the way through there, then you are behind. So we've got some work to do, but I'm going to go over 2.03 and talk about what that is. This is all about solving radical expressions. So the first thing we need to do, and it does this in our lesson, is identify what is a radical expression. So let me put this up here. Right? Okay, I have two expressions up here, two equations. I got a square root of x plus 2 equals 7. All right, I can even cut this back. Let's just make it the square root of x. The square root of x plus 2 equals 7, and x plus the square root of 2 equals 7. One of those is a radical equation. One of these is not a radical equation. This is a radical equation. This is linear because this is x plus a number. Square root of 2 is just a number. That's the same as saying like x plus 1 equals 7. We're just saying x plus the square root of 2 equals 7. It's just a number. This is just a linear equation over here. This is not a radical equation. A radical equation has a variable underneath the radical. The variable is underneath the radical. So this is a radical equation. And this week is all about solving radical equations. So let's get this one to solve. Let's start with 5x plus 4 equals 7. And we're trying to solve this for x. And we've got this big radical thing to deal with here in our way. So to get rid of a radical, you got to do the opposite operation, right? The opposite operation is squaring it. So let's square it, which means we need to do that to both sides, right? We can't do anything to one side that we don't do to the other side. So we're going to square it. So anything that is underneath the square root that we have now squared just equals itself. Is it like the square root of x squared just equals x? Whatever's underneath there just equals itself. And the other side equals 7 squared. 7 times 7 is 49. So 5x plus 4. Now we're just solving a linear equation. 5x equals 45. Divide by 5. X equals 9. So x equals 9. Now here's something with radical expressions. Sometimes you can get answers that are extraneous, which means they're extra. They solve mathematically, but it doesn't actually work. So we always have to check by taking that and going back to the original equation. The square root of 5 times 9 plus 4 equals 7. 5 times 9 is 45 plus 4. So we have the square root of 45 plus 4 equals 7. Square root of 49 equals 7. And yes, that is 7 equals 7. So this works. This is a good solution. X equals 9, and it's not extraneous. Not extraneous. And in your assignment this week, it will have you solve problems, and it will say, it'll give you multiple choice, and it would have like X equals 9 is one of your choices, and it says this is not an extraneous solution. And it may have X equals 9, and this is an extraneous solution. Then like X equals 4, and it's not, and X equals 4, and it is extraneous. So you have to go back and check anytime you're dealing with a radical expression to make sure the answer you have doesn't get thrown out as being wrong, right? As being wrong. That doesn't work. So since this one works, this is good. Let's look at another problem over here. I'm going to draw a line and separate this. All right, now we're going to work X minus 3 plus 4 equals 1. All right. I'm sorry, I said X minus 3 and I wrote down minus 4. I was looking ahead at my X. The square root of X minus 3 plus 4 equals 1. Okay, we know we're going to have to square both sides, but we don't want to do that until we have only the radical on that side, only the radical. We got something extra. We need to move it to the other side first. So now we have the square root of X minus 3 equals negative 3. Now we can square both sides. Square. So this becomes just X minus 3. And this is negative 3 squared, which is 9, because negative 3 times negative 3 times negative 3 equals 9. So add 3, X equals 12. Now we check. The square root of 12 minus 3 plus 4 equals 1. Okay, so 12 minus 3 plus 4 equals. So the square root of 12 minus 3 is the square root of 9. Was our original equation plus 4? Yeah, it is. Plus 4 equals 1. Square root of 9 is 3 plus 4 equals 1. Does not work. So X equals 12 is a solution, but it is extraneous. Extraneous. This is an extraneous solution. So while it does work when we solve the math, it doesn't work here. When you do square roots solving radicals, we're always assuming the positive. If we would have assumed, because the square root of 9, there's actually two different roots, right? 3 times 3 or negative 3 times 3. If this is negative 3, that actually works. But that's not how we work when we're checking those. We always check the positive. We come out the positive, and it doesn't work. 12 is extraneous because we put that in there as a 12, as a positive, and it does not work. So extraneous solution. So it works as a solution, but it doesn't work in the problem. Let's look at another one. How about if we had a number out front like this? 3 square root of X plus 7 equals 12. So this one, there's something extra again. We can't square both sides yet until we divide by 3. X plus 7 under the radical equals 12 divided by 3 is 4. Now we can square both sides. Remember, always get this radical by itself first. X plus 7 equals 16. Subtract the 7. X equals 9. Does that work? 3 times square root of 9 plus 7 equals 12. So this is 3 times the square root of 16 equals 12. Square root of 16 is 4. So 3 times 4 equals 12. 12 equals 12. So this is good. It is not extraneous. Not extraneous. Actual solution. All right, let me see. I'm gonna do 2 more. Doing plenty of examples today because we only have one lesson. and a quiz. So I want you to have a good look at this. So let's do this one. How about when we have both sides having a radical? Radical on both sides. Now, here's the nice thing. There's nothing but a radical on both sides. We don't have anything extra. There's no 2 outside the front or anything. We're just squaring both sides. So the square of that is just 3x plus 7. And the square root of 19 is just 19. Minus 7. 3x equals 12. Divide by 3. X equals 4. Let's check it. Square root of 3 times 4 plus 7 equals the square root of 19. 3 times 4 is 12 plus 7. We have the square root of 19 equals the square root of 19. Those two numbers are identical. This is the solution, and it is not extraneous. Not extraneous. All right, we have one more case I'm going to show you. And this is where it gets a little... Okay, may have had just a glitch with the internet there. All right, so we've got, once we move the 3 over, we've got square root of x minus 3 equals x minus 3. We're going to square both sides since we have the radical by itself. So this is x minus 3, but this is x minus 3 times x minus 3, which is x squared minus 6x plus 9. It makes a quadratic. Don't forget about that middle term. We do the first ones, x times x. We do the last ones, negative 3 times negative 3. And then the middle term is the outside ones multiplied and the inside multiple ones and add together. So x minus 3 equals that. Then we got to move everything to one side. So I'm going to add 3 and subtract x. We got 0 equals x squared minus 7x plus 12. And now we're in one of those factoring things, all right? Yes, Darby, do well. Darby's having to leave for her tennis match. So then when we factor, you can use the quadratic formula, or you can factor this, completing the square, however you need to do that. But that is going to end up being x minus 3, x minus 4, where it factors to get to that. So that means x minus 3 equals 0, or x minus 4 equals 0. So x equals 3 or 4. We have two answers because it's quadratic. There's two x's. We have to check both of those. So if x equals 3, the square root of 3 minus 3 plus 3 equals x, which x is 3. Well, 3 minus 3 is 0. So the square root of 0 is 0. So 0 plus 3 equals 3. So this is just 3 equals 3. That one checks out. It is not extraneous. Let's see if 4 also works. The square root of 4 minus 3 plus 3 equals 4, because we're just substituting x equals 4 into both of those places. That's the square root of 1 plus 3 equals 4. The square root of 1 is 1. 1 plus 3 equals 4. Both of these solutions are correct and are not extraneous. Neither one of those are extraneous. They both check out when we check them. So don't forget, anytime dealing with a radical, it's really good anytime you solve for x to go back and double check, but you have to with a radical because sometimes you get problems like this one we had over here where we come up with a 12, but when you put 12 back into the equation, you end up with 7 equals 1, which is not right. That doesn't work. So that's it. That is a nice look at all the different types of radical problems that you'll see in here. I hope that's all the different kinds. That's a big bunch of the different kinds of ones you'll see. So we have lesson 2.03. You'll have an assignment after that, our usual, probably 5 questions. I think it was 5 questions. And then our quiz. And our quiz will be over lessons 1, 2, and 3. So don't jump right into it if you haven't got all 3 of those assignments done, because you want to do well. That counts as an evidence of learning grade. All right. The quiz always counts as a evidence of learning grade. So if you got any questions on any of that, please ask me before you take the quiz. You can email me. You can come to our next class on Wednesday with questions, whatever you need to do. But, this isn't due until Sunday. So a little shorter week. Maybe you won't have to spend so much time on math. You can get caught up on other things or get ahead on other things, whatever you need to do. But if you have any questions, hang around. Otherwise, I'll let you go. We'll be done.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.